Hey guys, this is Mr. Grady welcoming you to another edition of CMA Math Academy. We are going to get started learning about functions today. So let's talk about what we're going to learn today, while we're learning this, and how you'll know if you've successfully learned it. So what we're learning today is how to determine if a graph or an equation represents a function and if it's linear. So we've already learned a little bit about functions from Mr. Schrog. We've talked about linear, that word, that means a straight line. We've talked about that in our other lessons in this unit. So we're just going to go a little deeper with it. So why am I learning this? Because functions come in many different forms. So again, graphs and equations. We've talked about ordered pairs and looked at tables and again did mapping with Mr. Schrog. And we need to understand all those different forms that functions come in. So today we're just learning about graphs and equations to add to our list of ways we've learned about functions. And then finally, how will you know that you successfully learned it? So at the end of class, you're going to have some work time. So you're going to be given an equation and a graph, and you're going to have to determine if the example that you're given is linear and if it's a function. So if you can do those things, you'll know that you've successfully learned what we're talking about today. So as we start today, you're going to need a couple things. The first thing you're going to need is your book open to page M2 214. Now we will use some other pages, but we're going to start on 214, so I'm going to give you a second to get that out. You'll also need your Cornell Notes from the other day. We took a lot of notes on Monday back, and we're going to use them. It doesn't make any sense to take notes and not look at them. So when we're going to take our notes, we want to go back, we're going to revisit them, reread them, look at some different things that are in our notes. So I'm going to give you about 30 seconds here to get out what you need out. So as you have your stuff ready, this is what M2 214 looks like. So again, I'll give you just about 2 more seconds here to get your stuff out and ready. M2 214. So as you can see by the title, it says functions as graphs. So we talked about today we're learning about graphs and equations. So we're really doing 2 sections today. So this first one has to do with graphs. So at the top we have some black lettering that just gives us some information on scatter plots. So we're going to read this together. Remember, when I stop, I need everybody reading the next word as a team. Nobody not participating. We're all doing this. Okay, so as I stop, everyone's reading the next word. Here we go. So it says, a scatter plot is of a collection of ordered that allows an exploration of the between the points. So you've probably used scatter plots before. As you see down below, we have 2 scatter plots. A scatter plot is just a graph where the points are all scattered around. They don't really make a lot of sense sometimes. There's not really a lot of format to them. That's why we don't connect the points, because if we did connect the points, it would just make our line look really crazy. So we just kind of leave the points as they are, and we figure out the information from the points that's given. So now let's look at the information that's in purple, our directions for today. So again, when I stop, you're reading the next word. So it says, determine if each plot represents a, explain your reasoning. Now I want you to take a second here, I want you to underline that word function. Okay, so we've talked about as a function, in our notes we wrote this, that as a function, the x values cannot repeat. So the x's cannot repeat. Okay, we've also said that that means for every x, there's one y. The x's cannot repeat in this case. Okay, so let's use that reasoning of the x's can't repeat to look at a and b. So let's just decide here if our graphs are in fact functions. So let's look at a. So let's look at the point that's at the bottom left. So if we look at our bottom left point, to get to this point from 0, we go over to 1 and up 1. So that ordered pair for our point would be 1, 1. Now remember, in an ordered pair, the x's come first. So this one has an x value of positive 1. Now remember, really all that matters is our x's. The x's can't repeat. Let's go to the next ordered pair. So our next ordered pair is a little bit higher. to get to that ordered pair, that point, we go right 2 and up to 3. So that means this ordered pair would be 2, 3. Again, the 2 that's in the x place, that's what matters. That's what we're looking at. Let's go to our next point. So our next point is right 3 and up 1. So let's write that point. Right to the 3 and up to 1. Again, our x value is what matters. Our x is a 3. And then our last point, if we look, is right 4 and up to 4. So that means our ordered pair would be 4, 4. Again, the x is what we're looking at. That's why I've underlined the x values. So let's look just at the x's real fast. We had a 4 on our last point. We had a 2. We had a 3. And we had a 1. So if we look at those values, did any of those x values repeat? Well, hopefully we said no, none of those repeat. So our answer for A is that A represents a function because no x values repeat. Alright, now it's your turn. I'm going to give you about a minute here. I want you to try B. So you're going to list out the ordered pairs. Tell me whether or not that's a function. Again, you're looking to see if any of the x's repeat. Alright, begin. Okay, so hopefully you had time to work. I'm going to give you a second now to share with your table partner. So I want you to share your points with your table partner and whether or not you decided that B represented a function or not a function. Ready? Begin. Alright, so let's check our answers together. So if we look through our ordered pairs, our first pair was again at 1, 1. So that means our x value was 1. We had another point at 2, 3. So that meant our x value was 2. We had a point at 4, 1. So our x was 4. And then we had a point at 4, 4. So we know by looking at this, and hopefully you and your partner discovered, that there's 2 places where our x value is 4. So we should have discovered with our table partner that this was not a function. And again, we had to have a reason. Remember, the reason for that is because x equals 4 2 times, and we can't have that. We don't want any x's to repeat. Okay? Now, this took us quite a while. And the good thing is that there's a much shorter and easier and quicker way to check a graph. Now we have this actually written in our notes, so what I'd like for you to do next is to go to the Cornell Notes section in your notes on graphing. So the section looks like the one that's on the screen. The only difference is you guys have already filled in the question column, you've already filled in the blanks, and we've really already discussed this a little bit, but I want you to go to this section. So when you've gotten to this section, I would like for, if you're partner number one, you're going to be reading your question. So I'm going to put a 1 in the question column. So ones are going to read their question, and then ones are also going to be reading the sentence at the top. Okay? If you're partner 2, your job is to explain the graphs. So ones are going to read their question and the sentence up at the top. Twos are going to explain the graphs and fill in those blanks below. You have about 45 seconds. Ready? Begin. Alright, our time is up. So here's what we're going to do. We are going to kind of discuss this a little bit. So if you look at your notes, you should have this written in. So again, in order to be a function, the graph must pass the vertical line test. So we haven't talked too much about the vertical line test. That's what we're going to get into right now. But hopefully you and your partner discussed it and talked about how the first one represents a function, and our second graph also represents a function, but our third graph does not. Now you might not have really understood why. That's our job to figure out today. So in your book, we're going to do a little bit of work reading, but we're also going to do some work outside of our book. So on the same page we were just on, 214, there's a paragraph that looks like the one that's up here that's talking about the vertical line test. So you need to find this paragraph. It's like middle of the page on 214. Okay, so again, when I stop, you're reading the next word as we go through this. Okay, everybody following along and participating. So it says, the vertical line is a visual method used to determine whether a, represented as a graph, is a function. To apply the line test, consider all of the that could be drawn on the graph of a relation. If any of the vertical lines, the graph of the relation at more than 1, then the relation is not a... Okay, I want you to take your marker, or your pencil, or your pen, or your highlighter, or something, and you're going to highlight that last sentence here that says, if any of the vertical lines intersects the graph more than once, or more than one point, the relation is not a function. So let's talk about what that really means, though. So you do not have these 4 graphs in your book, but I still wanted you to see what it is. I think this will be a little bit better understanding of it. So let's go through this for a second. So on our first graph here, we have a line that's just a straight linear, because it's a straight line, vertical slope, positive slope line. Okay? If I take my pencil and run it across the line, okay, you can see that if I stop, the line only goes through my pencil one time. If I move it over here, the red line, my graph, only goes through my pencil one time. So if it only crosses one time, that means the relationship or the graph is a function. Okay? Now, let's think about what might make a graph like this. This kind of line, this kind of graph is what we've seen so far. This is a graph that you would see if you wrote an equation in slope-intercept form. So y equals mx plus b would give us a line like this. Okay? Let's move over to our second one. Our second graph is a U shape. This is actually called a parabola. Everybody say parabola. So if I take my pencil and I just stop it on my line, you can see my graph only cuts through my pencil once. If I move it over here, again, my graph only cuts through my pencil one time. Because my graph only cuts through my pencil one time, again, this represents a function. This graph would be made by an equation that has like an x squared. So anytime we have a squared as an exponent in our equation, it's going to give us this parabola shape. So this is when we have a squared. Okay, let's look at our third graph. So if I put my pencil on this graph, you can see that it cuts through my pencil 2 times. So this is still a parabola, just like what we had up here, but since it's on its side, it's going to cut my pencil twice. Well, we've talked about if it goes through our pencil twice, then that doesn't pass the vertical line test. That means this is not a function. Okay, this kind of graph is still squared because it's a parabola, but this would be if we had y squared. So if our equation we know now has y squared, it's not going to work for us. It's not going to be a function. And then the last one we have is kind of weird. We've talked about this kind of slope. Okay, this is called an undefined slope. Everybody say undefined. So an undefined slope is this vertical straight up and down line. So this is a linear, it's a straight line, but if I put my pencil on it, it's going to be completely covered up. So really what that means is it's crossing my pencil everywhere. So it's definitely more than once, and that one would be not a function. So again, if the pencil is crossed one time, that's a function, like these two up here. If it's crossed twice, or even 3 times, or like in this case, basically the entire time, not a function. So you're going to have a chance here to practice this. On M2 215, I'm going to give you about a minute here. You're going to answer questions 2 and 3. So 2 says, use the definition of a function to explain why the vertical line test works. So what you were thinking about is, what does it mean when the pencil is hitting the line twice? What is that saying about our values? Think back to the one we did in our book on 215, so just up above this. Or what does it mean about our x values when it's only hitting once? So you're going to explain that. Then it says for 3, use the vertical line test, so you can put your pencil on there on the paper. To determine if each graph represents a function, you need to explain how you know. So does it pass the vertical line test or not? Okay, so I'm going to give you a second here, and you're going to work on 2 and 3. Alright, so you guys have had some time to work. You're going to get some partner time now. So if you're partner number 1, you guys are going to be explaining question 2, so your explanation about the vertical line test. And if you're partner number 2, then you're going to be showing your answers for A and B down below on the graphs. Okay, ready? Begin. Alright, so hopefully you've had some time to share. I specifically want to review real fast question 3, so let's look at A and B. So remember, the vertical line test says that our pencil can be crossed more than once. So if we look at A, on 3 we're going to say all together either function or not a function. So your answer options are either function or not a function. Here we go, on 3 for A. 1, 2, 3. Very good. You should have said not a function. So this graph is kind of weird. It's actually made by our absolute value. So that's what these two lines mean. So the absolute value of a y value gives us this sideways v. So if it's the absolute value of y in our equation, that's not going to be a function because it makes this sideways v that gets crossed twice. Let's go over to B. Again, on 3, we're all going to say our answer, either function or not a function. Ready? 1, 2, 3. Very good. We should have said this was a function, and this v graph is made by the absolute value of x. So that's okay. That would work. If we have an absolute value of x, that gives us this v shape, which is a function. Okay, so let's move on now. You're going to go to your Cornell Notes, so move back over to your Cornell Notes, and I want you to find the section on equations. So again, you should have the question filled in and this 3-column section filled in. I'm going to give you a second to get to there. Okay, so here's what we're going to do. If you're partner number 1, partner number 1 is going to read their question and the first column about functions. If you're partner number 2, you're going to go over the not a function column and the linear or straight line column. Okay, so you guys are going to have about a minute to go over this information that you already have written down. Ones are starting us out. Ready? Begin. Alright, so hopefully you had a chance to read over the information we wrote down. Let's look at it a little closer now that we have everything filled in. So just a quick review that you already have. For an equation to be a function, so we're over here in this first column. For an equation to be a function, it can be written in slope-intercept form. Remember, that's y equals mx plus b. That's one option. It could also be a function if only the x has an exponent. Remember, an exponent is like squared or cubed or to the 5th power. So if it's on the x, that's okay. And it could also be a function if the only variable in the equation is a y. So if we didn't have an x at all, so if it just said y equals 10, that would be okay. Let's look at if it's not a function. So if it's not a function, an option for our equation would be if the y has an exponent. So if our equation says something like y squared, it's not a function. Another option is if the only variable is the x. So if you remember back up on our other page, I showed you a graph that was just a vertical line. Well, that vertical line is made by x equals 3 or x equals 4. It's a vertical straight line, and it's not a function. Finally, let's talk about linear. In order for the equation to represent a linear graph, it can have no exponents. So again, slope-intercept form was good because normally it has no exponents. If there's an exponent, it automatically rules it out from being linear. Okay, so let's move on and let's look at your book. So you've got this page 217 that has some equations on it. It says determine whether each equation is a function. Now it has some extra directions that we're not going to worry about. Right now we're going to determine if it's a function. So this is, we are definitely doing this first part. Go ahead and underline that. Okay. But rather than doing the list the ordered pairs, what I want you to add to your directions, so put a star here, is you're going to say whether it is linear or not linear. Okay? So you have to also put linear or not linear. So let's look at a couple of these. Let's look at A. So A says y equals 5x plus 3. Well, we know from our other work that that is written in slope-intercept form, y equals mx plus b. If we look at our three columns that we just looked at, if it says slope-intercept form, that tells us that this is, in fact, a function. Okay? Now, if we want to think about what it would look like, basically this graph is just a line that looks like this on our graph. So it is a function, because if I put my pencil on there, it's only crossing once. Now, the other thing we need to say is whether or not it's linear. Remember, in our three columns, it said to be linear, it can have no exponents. Well, if we look through our equation, this equation has no exponents. So this is fine. So this equation is a function, and it is linear. So it's both of them. Okay, let's look at B. Let's try B together. So B says y equals x squared. So let's first talk about if it's a function. Now again, looking at our three column notes that we have, if the exponent is on the x, that's okay. That means this would be a graph like we had up above. That's a parabola. It would look like a U shape. So this graph is a function. Okay, but let's think about, is a U shape a straight line? Well, no, it's not. So this is not linear. If you didn't know that this equation made a U shape, then what gives it away is this exponent. That's 2. Remember, to be linear, it cannot have an exponent. Okay, so we're going to do C together, and then you're going to do D, E, and F. So let's go down to C. So C says y equals the absolute value of x. So let's think back to the graph we looked at a minute ago. We had a graph that had the absolute value of x, and remember, that was a V shape. So it looked like this. So we know from our previous question that we did that this graph was a function. Okay, so I could draw a line. It would only be crossing once. But is a V linear? No, it's not. It's not straight. So this is not linear. Okay, so I'm going to give you about 30 seconds to do D, E, and F, and then you're going to move on to some more practice on your own. D, E, and F. All right, so let's look at these. So D said x squared plus y squared equals 1. So on 3, we're only going to say if it's a function or not a function. So on 3, function or not a function. Ready? 1, 2, 3. Hopefully you said not a function. This is not a function. Okay, and again, the reason is we have a y squared, and then we have several exponents. We have an x squared and a y squared, so this is also not linear. So it's not a function, and it's not linear. Let's look at E, y equals 4. On 3, we're going to say if it's a function or not a function. Ready? 1, 2, 3. Very good. This is a function. Okay. And this again is linear. So we know from past experience that if it's y equals 4, what that's saying is that if we have a graph, then every value is at 4. So it looks like that. So it's linear, and it's a function. Finally, we have x equals 2. So we're going to say that answer for a function on 3. So it's either function or not a function. 1, 2, 3. Very good. You should have had not a function. So it's not a function. And is this linear? This is linear. Remember, this is a straight line up and down. So this is linear. So now you're going to have some chance to practice on your own. So there's going to be a worksheet that's passed out to you that has a front side about linear graphs and function graphs, and a back side that has linear and function equations. You can work with your table partner on this if you need help. And that will do it for this video edition of CMA Math Academy. Have a good day, guys.